So in this case, we are going to continue with our integrals, which was question number 2.3. That was a 4-mark question. We are given to integrate this part of y with respect to x. So that was the integral of tan to the exponent of 4 half x like this. So we must integrate this whole part with respect to x. As we can see, we have got a trigonometric function, tan, which in our integrals, remember when we consider tan, we have got the integrals of tan to the exponent of, all right, so let us just have this integral here. Let's say it is tan to the exponent of n of ax. Whenever we are being asked to integrate this and the value of n is less than or equal to 5, we can have conditions where some of the numbers are even, some of the numbers are odd. So in our case, the exponent there is what? Is an even exponent. So we are going to use the condition that is for n is equal to 2 or n is equal to 4. All right, I think I talked about that one as a separate topic, how to integrate this part of our tan. Okay, so on tan, we are going to notice that it is one and the same substitution that we are going to make, whether it was even for the odd powers. We are still going to use the identity of tan, which is from our formula sheet. If we are to consider, we need this one, this identity here. 1 plus tan squared of x is equivalent to sec squared of x. So we are going to transpose and make tan squared the subject of the formula from there. All right, so let's bring that identity, as we saw that if we make tan the subject, it's going to be tan squared x is equal to sec squared of x minus 1. We are just transposing, taking the 1 to the other side, so it's going to be negative 1 there, which is okay. If we are given anything for tan of x, but this is half of x. So let's try to notice something here. We can see that there is no change in terms of what we are given on our variable x. If it is x, this is going to remain as x. So in actual sense, let's say this is ax, this is going to be ax. There is no change that is going to happen, like maybe you had something like cos 2x, then at the end you are going to have something like 2 sine squared, or all right, we're going to have this one cos squared of x minus the sine squared of x. Let us just use this one. We can see that there was a 2 here, but this is now 1, this is now 1. The coefficient of x has been affected. On this part, it is not affected. The a that we have here is the same a that you have there. So meaning to say, if it is tan to the exponent of 2, all right, there we need this half of x. So if it is tan squared half of x, as we can see, guys, our a is what? Is a half there. It is going to remain as it is. So it's going to be sec squared half of x minus 1. So that is what represents the tan squared half x. This is what we have. So how to expand for when you are given the even exponent? That is when you're dealing with 4. Because when it is tan squared, there's no need for actually you to apply that, because you can still use the formula sheet. Remember, from our formula sheet, we can integrate the tan squared, the tan squared. We have got this one here. So it is not that important that we are going to talk about how to integrate when it is tan squared, because it is there in your formula sheet. So you can just use the formula that you are already given to integrate what? A tan squared. So this part is particularly meant, it is meant for the what? For the 4, the power of 4, the exponent of 4. Okay? So how do we expand it now in terms of a tan squared? The tan to the exponent of 4 that we are given here is the same as tan squared half x, like this, times we're going to have another tan. So if we were going to square it, I want you to see this part here that I do not want you guys to follow. Let's say you're going to square this. It means you are going to square this part, because that is the one that represents the tan. So it was going to be sec squared, because some of us ask, why is it that we do not square this one? So let's say you had to square this one. Remember, your identity of a minus b squared was going to be a squared minus 2ab plus what? Plus b squared. So that was going to give us this. If you square it, it's going to be sec to the exponent of 4, half of x. Then you multiply these two, multiply it by 2. So it's going to be sec squared half x. Then we square the 1. So 1 squared is what? Is 1. This is what you're going to have, which is going to be difficult, guys, for us to integrate. Look, we've got sec to the exponent of 4. How can we integrate that? It's going to be difficult. So even the sec squared on its own, because if we check, okay, let's go to our integrals. Remember, integrals, the reverse of what? A derivative. When you are given a sec squared, all right, let's say it is a sec squared, we can get it back to this one. But now let's say it raised to a certain power. It's going to be difficult actually for you to reverse to that one, which you can work with. Which you can work with if you understand how to. But the easier path here, if we check, all right, the reason why we are going to use this other one that I'm going to explain now is that if we check the part where we have got there's a sec squared, all right, let's go to the derivative. I want us to go to the derivative, all right, where there is a sec and a tan. So if you check, there is a sec and a tan, which we can play around because we know our substitution can work in order for us to have that reverse. Even if a sec is being raised to any exponent, this one, it can be raised to any exponent, like let's say squared to the exponent of 3, you can make proper substitutions on that one. All right. So, guys, why am I even explaining this? It's enough. So, the easier path for us to have a tan and a sec is to expand this as tan squared times tan squared. So, it's going to be tan squared times tan squared. The reason is we need to substitute one of these tan squared with this part so that we can obtain a part where there is a tan and a sec, and at the same time there is a tan squared. Remember, I told you it is easier for you to integrate tan squared because you've got that one in your formula sheet. So that can be easier path. All right, so let us substitute one of these. So I'm just going to replace this one with this equivalent. So it means that's the integral of tan squared half x into what we obtained from that equivalent from our identities. It is one and the same. We are just saying these two, they are equal. So we can substitute in place of that tan squared half x with its equivalent, then integrate with respect to x. All right, so this is where we are. Let us expand our brackets. So this is going to be the integral, distribute throughout the bracket. So tan is going to multiply the sec squared. So that's going to be tan squared half of x, sec squared half of x. So since we are going to have two parts, we're supposed to have this bracket and this one multiplies here. Then we're going to have our dx. So guys, we're just going to separate those two parts. So this is what I'm going to do. I'm just going to write this one on its own. Then tan multiplies the negative one. It's going to be negative tan squared half of x with respect to x. So I'm just going to separate that way our integrals so that we can integrate each separately. The tan squared, we have it. Remember, we have it, the integral of a tan squared, so there is no need for us to split again. We can simply take it from our formula sheet. We can integrate that one. All right? But if we check now, there is a part where we are given the tan and the sec squared, both being squared. So we can play around with the substitution there. All right. So on our substitution, remember we need to get rid of one of these two. All right. Using use substitution. So we need to get rid of one of these two. It's either tan or a sec. So which one are we going to choose to represent the u so that we can differentiate that part of what? That part of u. We can differentiate. Which one is easier to differentiate? Is it a tan or is it a sec? If we were to differentiate a tan, remember it gives us sec squared. Okay, let's go back to our formula sheet. Some of us, we need to be there on our formula sheet. Let's go back. That's a tan, this one, but let me use this one on top here. So if you check the tan, when you differentiate it, it gives us what? Sec squared. But if you differentiate a sec, it's going to give us sec tan. There's going to be a sec and a tan. We are complicating here. But a tan is giving us a sec squared, which we can cancel with what we are given here, the other sec squared. Remember, the condition is supposed to cancel with another one. So if we choose our u to be a tan, that is the best way. Because its derivative gives us what? A sec squared, which we can cancel later on. So the derivative of u with respect to x, as we saw, is going to be a sec squared. So that is half sec squared half of x. So this is our du dx. So what are we going to need from this one? It is dx. We need to get rid of the dx here. So we are going to make dx the subject of the formula. All right, so let us just quickly do this one. We can just even by sight, by just looking into it. All right, or you can just cross multiply, no problem. For the sake of us all understanding, you can just remove these two multiplies here. So it's 2 du. Then this one is going to be sec squared half of x dx. So I'm going to divide by this sec squared. So therefore dx is equal to 2 over sec squared half of x du. So the du is on top. So this is what our dx represents. All right, so guys, this is a calculation that you are going to just do aside. Then when you are to substitute that part that we are given, all right, sorry for this, I'm just going to add another device here. Okay, sorry for that. So if we were to add this part on our integral, we must substitute. So it was going to be the integral of, remember the whole of this tan is represented by u. So here I'm just going to write it aside. So it's going to be u squared times the sec as it is, Just doing this step for everyone to properly see, because some of us will be asking to say, what happened? How did we get rid of that dx? So this is our dx, this one. So it's 2, right? Let me put it this way. So it is 2 over what? Over sec squared half of x. Du like this. So this is the part that I was explaining to say we must have a condition where these two will cancel. So let's say you chose that one that was having a sec and a tan. It was not going to cancel. You're going to have a sec and also a tan. So you see, when you cancel, you remain with a tan, you remain with a sec. So that is what we did not want. So we had to find something that gives us exactly what you see on the other part, sec squared, which is exactly this one. So these two can cancel. So we are left with the 2 and u squared. So this is the part that you can even indicate here. So you can indicate to say this whole part is going to be given as the integral of u squared. So taking this 2 out of the integral, because it's a constant, we can write it as 2. Then there is what? Du there. So we must integrate this with respect to u minus the integral of this. Let me just rewrite it. We're going to just integrate both at once. Let us just do this, guys, simultaneously. Let us integrate them. So this is it. So this is a calculation that you can make aside. Then just substitute here. Indicate now your integral of u with respect to you, guys. This is u to the exponent of 2. So we're just going to add 1. So that is u to the exponent of 3 over 3. But remember, there is a constant 2. So if you multiply by 2, it is going to be 2 over 3 u to the exponent of what? Of 3. So we have integrated with respect to what? With respect to u. Take note. Minus the integral of tan squared, which we are not supposed to be scared of or to expand, guys. There's no need, because we have this one in our formula sheet. Let's go to our tan squared. I think I showed you guys here. So this is what we have on our integral of tan squared. So ours, it is, I'm just going to write it here. It is tan squared half of x, remember? So our a represents half. So where we see a, we're going to put a half. So that is going to be a half here. Here it is going to give us a half again. Okay. So in place of x, guys, as you can see, it is ax. The x is not affected. The only part is of a. So it is 1 over half of a. All right. So this is the stage that we were going to write. So let me just rewrite as it is the way that I wrote this. So I said it is going to be what? This whole thing is going to give us 1 over our a, which is 1 over 2. Tan ax, which is tan half of x as it is, minus x. So that is the whole integral plus the constant of what? Integration. So that is it. So we can simplify this substituting our u. Remember, this is u, which is not part of our question. So let's take back our u, which is the tan of half x. So that was going to give us 2 over 3, and that's tan half of x to the exponent of 3. So that's to the exponent of 3 like this. All right, remember, tan squared is same as tan squared x. It's just one and the same. So this is it even for the exponent of 3. Minus, simplifying inside of the bracket. All right, so there is 1 over this, which is going to give us 2. So it was going to give us 2 tan half of x minus x. All right, so let us expand with the negative that is outside of the bracket. So expanding by that negative, this is what we are going to have, of which you can even leave it like that. You can even just leave it like that. You're done. So negative times this, that's going to be negative 2 tan of half x negative times negative, that's going to be positive x. Then we have got our constant of integration at the end. So as we can see, that is how these integrals can be direct as you can see, if you are working with trigonometric functions, there is a trigonometric function. You must consider exactly the format that you're given so that you know how to expand it on your integrals. All right, because they can be of a tan, they can be of a sine. So make sure that you go through the basics, which is the introductions of each, so that you know how to expand each and every integral. It's a repetition, guys. As you can see, they do repeat these questions. So that is it till we meet again.